Hello everyone. With full enthusiasm, I am back again in front of you for my videos. Welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who still didn't subscribe, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the day. This scientist was born in the year 1920. This scientist is from UK. This scientist belongs to molecular biology, and this scientist is known for structure of DNA. This scientist made her wonderful contribution to find out the structure of DNA, but her consent or her work was taken by Watson and Crick without her knowledge. This scientist made this or found out the structure of DNA by X-ray crystallographic studies. This was one of her doctoral study. This scientist was very good at physics and chemistry. This scientist, friends and relatives call her as a very kind-hearted woman because her work without her knowledge was taken by another two famous scientists called as Watson and Crick. So, she was called as Dark Lady of DNA. That is, people call her as Dark Lady because such a wonderful structure of DNA was found out by her, but the credit has gone to Watson and Crick. This is because her close relative and or a friend or a co-worker, Wilkins, has taken her work and gave it to Watson and Crick due to the conflict between this scientist and Wilkins. So, her unpublished data was left as such like that. Thus, you might have guessed who the scientist is. This scientist was Franklin. Rosalind Franklin was the founder of structure of DNA actually, and she died because of ovarian cancer at the age of 36 itself. She was called as a very kind-hearted woman. Her wonderful contribution and brilliancy has led to the beautiful structure of DNA in crystallographic studies. Moral of the story from this scientist: be very confident in any situation and please stand up for your own worth. Welcome back to the channel. In my today's video, I will be continuing with Chapter 2 ICSE Class 10 Physics, that is Work, Power and Energy. In my last video, I have ended up with the introduction about work done, its definition and its units and 3 different cases. In this video, I'll be again recalling what work done is, and then we'll talk about energy and power also. Let's again recall the definition of work done. What is work done? Work done is the product of amount of force applied on an object and the body then displaced due to the force. Let's see. Work done is equal to F, the amount of force applied on an object, and S is the displacement, how the body is displaced due to this force. If the direction and the displacement is different, then it will form an angle. So that angle can be measured as cos theta. Now, there are 3 cases. As we have seen in our last video, there are 3 cases of work done. If the body is displaced in the direction of the force, if the force is applied in this direction and the body is also applied in this direction, then the angle formed between them will be 0. because both are in the same direction. The angle formed between them will be 0 only. So 0 degrees. So cos 0 is 1. Now work done is equal to Fs cos theta. So F into S into cos theta is 1. You will get work done is equal to F into S. That is positive work. This is in case of force applied on the body and direction of the object moving or displaced is same. Second case, the body is displaced opposite to the force, to the direction of force. So the force is applied in this direction and the object is moving in this direction. Both are opposite. So if both are opposite, that is the force applied and the body displaced is opposite, the angle formed between them will be 180 degree. Cos 180 is minus 1. So work done is calculated as F into S cos 180 or minus 1. You will get minus Fs. So if work done is minus, we call that work done as negative work done. Next, third case. If the body is perpendicular to the direction of force. For example, I am applying force this way and the body is displaced perpendicular. Okay, the force is applied in this direction. The body is moving in the perpendicular direction to the force. Then the angle formed is 90 degree. See, the force is this way and the body is moving this way. So the angle formed between them will be 90 degree. So cos 90 is 0. If cos 90 is 0, work done F into S into 0 will become 0 totally. So work done is 0 and you call that work as 0 work done. So we have seen positive work, negative work and 0 work done. Continuing with work done by different forces. We know that centripetal force. What is centripetal force? If the force acting on an object and the object is moving in a circular path, force applied, the centripetal force will act away from the object or towards its center. Take for example, I am taking a stone and I am circulating it. So the object is moving in a circular path. Where is the force applied? The force is applied towards its center of the circle. That is why it is called as centripetal force. In such case or in such type of force, what will be the work done? How work done is calculated? Let's see. So work done by centripetal force. Body, if the body is moving in a circular path, centripetal force acts on the body, tries to pull the object towards its center, of course. Isn't it? Always the force will act towards its center. Then, since centripetal force, then where is the force? Force is applied in the center. Object is moving around. Force is in the center and the object is moving away from the force. Isn't it? So, centripetal force is acting away from the object. And displacement is also away. Where is the object moving? The object is displacing in a circular path away from the force. Force is acting towards center. So this is your center, assume, and the object is moving in a circular path, that is your displacement. Object is away from the force and displacement is also away from the force. Thus, in such case, see, this is the object and we are circulating it in a circular path. Force is acting towards the center. We call it as centripetal force. Where is the object displacing? The object is displaced in this direction. So, the angle formed between them will be 90 degrees. Yes? Okay. So, in such case, work done is equal to F into S cos theta, where cos theta here the angle formed is 90 degree. We know that cos 90 is 0. So, work done will be 0. So, if the work done is 0, then it is 0 work done. Yes, in such case work done by centripetal force is 0 work done. Next, work done by gravitational force. What is gravitational force? When the mass of an object or when an object with certain mass is being pulled by the earth, the object will be moving towards, the force will be applied away from the object towards the earth. That is your gravitational force. Okay. In such case, how will the object, where, in what direction the object is displaced? Force will be downwards and the object will be, let's see, in two cases. See, work done by gravitational force. Assume I am object is thrown vertically upwards. In such case, I am taking an object, any stone, and I am throwing it upwards. Okay, so the force of gravity will always act downwards and object is moving upwards. So see, force of gravity, Fg is force of gravity acting downwards and the object is displaced upwards. Since it is height, I have written it as h. So Ws cos theta. What is the angle formed between them? If the force and the object displaced is opposite direction, they form 180 degrees. So cos 180 is -1. So work done will be minus Fs. You call that as negative work done. If it is minus Fx, we know that F is equal to mg. We know that by Newton's first law of motion, F is equal to mg. M is the mass of an object and g is the gravitational force. G is gravity. So F is equal to mg. We are substituting this mg in place of F as minus mg, and S is the displacement. As I already said, displacement, since it is moving to a height, I have written instead of S as h. So work done is mentioned as minus mgh, which is your negative work done. This is in case if the object is moving or thrown upwards. What if the object is falling? I am pulling the object from top to bottom. So a heavy weight is being lifted up and then I wanted to put it down. Object is put it down on the ground. I am lifting something up and I have to place it on the ground. Okay, so the object is moving downwards and the gravitational force is also moving downwards. So both are in the same direction. In such case, if both are parallel, see, the force and the displacement is parallel, W is equal to Fs. We know that because when this both are parallel, it is 1 actually. So W is equal to F into S. We know that F is equal to mg. Then W is equal to, substituting this mg here, mg, and this displacement we are writing it as height h. So W is equal to mgh, which is your positive work, and here it is negative work. So the work done will be negative if the object is thrown vertically upwards. If the object is moving downwards towards the earth, then the work done will be positive work done. Continuing with work done with different forces. Let's take two different forces. That is, if we plot a graph against force and displacement, how do we get a area? If we are taking a constant force, that is, if force is taken in the y-axis and all the force is only same unit. For example, let me take, if the force applied on the body is 10 Newton, throughout the y-axis it is only 10 Newton and x-axis differs. That is constant force. If the force applied on the object is same, 10 Newton, 10 Newton, 10 Newton only, then how come we will get a graph? Let's see. So constant force. So the force acting on the body is same. It's only, for example, if I am taking as 10 Newton, the body is displaced by same force every time. Then the graph plotted between F and S, you will get like this. Here, this is your y-axis. I have taken force, unit of force is Newton, and Every time the object is displaced. See, we have different displacement. Displacement is taken in the x-axis. That is your S measured in meters. So, object is displaced 2 meter, 4 meter, 6 meter and 8 meter. But the force applied on the object is 10 Newton only. So, you will get a rectangle. You will get a rectangle in the graph. So, the area of rectangle, if you have to calculate the work done, you can calculate it by area enclosed in this graph and work done. How do you calculate its area? It is your BA and BC. We know that area of a rectangle is the sides A, BA and BC. What is BA? BA is your force. It is 10 Newton. And BC is your displacement. Displacement is S. So that is your 8 meter. So force 10 into displacement is 8. So totally 8 joules is your work done in case of constant force. Let me take if the force is varying along with the displacement. Displacement is also varying and the force is also varying. Let's see. For example, if force is 2 Newton, 4 Newton and 6 Newton and displacement is also 2 Newton, 4 Newton and 6 Newton. If we plot a graph, we will get a graph like this. See, this is your force 2, 4, 6 and 8 Newton. And then this is your displacement 2, 4, 6 and 8 meters. We are getting for 2 meters it is 2 Newton, for 4 meters it is 4 Newton, for 6 meters it is 6 Newton and then for 8 it is 8 respectively. We will get a slope like this. If we are getting a slope, definitely we will have a right angled triangle. So this is triangle. So if we calculate the work done, that is your WD is your work done. Work done is nothing but the area of the right angle triangle. Yes, the area of a triangle we can calculate it by half into breadth into height. Length into breadth. That is your work done. What is your length or breadth here? 8. And what is your height actually? It is your 6. So if we substitute this, we will get 24 joules. So that is your work done for variable force shown in the graphs. Units of work done. Work done is measured by joules. So how will you define 1 joule? 1 joule can be defined as if a force of 1 Newton displaces a body in a 1 meter, then the work done is said to be 1 joule. Let's see. SI unit is joule J. 1 joule of work is said to be a force of 1 Newton displaces a body through a distance of 1 meter. Okay. Then what are the bigger units of work done or joule? 1 kilojoule. We know that 1 kilo is 10 to the power 3 joules. So 1 megajoule is 10 to the power 6 joules. Then 1 gigajoule is 10 to the power 9 joules. These are the bigger units of joules. So with this, work done is over. Then we will go to the next topic of this chapter, power. As the name says, what is power? Let me tell you an example. I am taking a person A and person B. Person A, both of them, a particular task is given for 1 hour. A particular task has been given for them. Maybe they both have asked to write an essay for 1 hour. Okay, maybe a teacher has asked them to write for 4 times. Let us take it for 4 times. 4 times the same essay has to be written by person A and person B. Person A has completed that essay, which is of 3 pages. 4 times within half an hour. And the same person, that person B, the second person, has done that or he has taken it for 1 hour. So, who has completed it? How will you calculate that? Who has done the more? That is, person A has completed it for half an hour and remaining half an hour he has written another 4 times. So, who has done more work? It's person A. So, how will you calculate that with regards to time? So, whatever unit you calculate with regard to or taking time into consideration, you call that as rate of. So, rate of work done is called as power. So, the rate of doing work is called as power. So, power is equal to work done by time. Or we know that power is directly proportional to work done. If a person is having more power, if the power is more, work done will also be more. But power is inversely proportional to the time. Then work done, we know that work done is equal to force into displacement. Okay, so power is equal to work done by time, I said. So what is work done? Force into displacement. So power is equal to, in place of work done, I am writing F into S by T, or I am taking F out, force out, and S by T. What is S by T? Displacement by time. We already know displacement by time is the definition for velocity. Velocity is defined as rate of change of displacement by time taken. So, this unit S by T is taken as velocity. So, can I write power is equal to force into velocity, where force is a vector quantity and velocity is also a vector quantity, but power is your scalar quantity. So, power is equal to force into velocity can also be written, and power can also be written as force into S by displacement by time taken, or power can also be written as work done by time taken. SI unit of power. Power is equal to work done by time taken. What is the unit of work done? Joule. What is the unit of time? It is second. So, power is equal to joule by second. See, power is equal to work done by time. For work done it is joule, for time it is second. So, power is equal to joule by second, or we can also write it as watts. The unit of power can also be written as watts. If, how will you define 1 watt? 1 watt can be defined as when 1 joule of work done, when 1 joule of work is done in 1 second, we call that as 1 watt. Or I'll say 1 joule of work is done in 1 second, then the power spent will be 1 watt. So this is how you will define 1 watt. Then 1 horsepower, you will measure the watts in horsepowers. So 1 horsepower is equal to 746 watts. So 1 watt can be written as, can I write it reciprocally? If 1 horsepower is 746 watts, 1 watt is equal to 1 by 746 horsepower. Then the bigger units of watts. 1 kilowatt is equal to 1.32 horsepower. Then 1 kilowatt is equal to, we know kilo is 10 to the power 3 watts. 1 megawatt is 10 to the power 6 watts. 1 gigawatt is 10 to the power 9 watts. Then if we are considering small units of watt, this is bigger units, this is smaller units. 1 milliwatts, milli is 10 to the power minus 3 watts. Then 1 microwatts, even more smaller, is 10 to the power minus 6 watts. So these are the units of power. We will measure it in terms of watts. So power is also over. Then we will go for the next topic, energy. What is energy? As the name says, energy is the ability to do work. If we have to do any work, we definitely need some energy. If energy is there, power will also be there. But any work to be done, we need certain amount of energy. So how will you define energy as? Energy is the capacity or capability to do work. E is equal to P into T. So the power into the time taken. So E is equal to, how will you calculate SI unit of energy? E is equal to P into T, where E is 1 watt hour. 1 watt hour is equal to watt, 1 watt into 1 hour. So watt is nothing but, we have already seen, watt is nothing but joule second, or I have written it as joule second inverse, and into multiplied by hour is nothing but, for 1 hour we have 3600 seconds. So 1 joule second inverse into 3600 seconds. So totally 1 watt hour is equal to 3600. Second gets cancelled and you will get 3600 joules is your 1 watt hour. 1 kilowatt, as I already said, kilo is 10 to the power 3. 1 kilowatt is equal to, 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt is 1000 or 10 to the power 3 joule second inverse into 1 hour is 3600 seconds. So second gets cancelled and then 10 to the power 3 into 3600 or 1000 into 3600. You will get 10 to the power 6. We have 1, 2, 3, 4, 5 zeros plus this one. We are again multiplying 1000 into 3600. We get 3.6 into 10 to the power 6 joules. Second gets cancelled. Then, so 1 kilowatt hour is equal to 3.6. 10 to the power 6 is nothing but, I have already said 10 to the power 6 is mega. So 10 to the 3.6 mega joules is your 1 kilowatt hour, the unit of energy. Next is different forms of energy. That is, first one is your heat energy. Heat energy, what is heat? When there is increase in temperature, we can call it as heat, isn't it? For example, I am taking a mass of 1 gram of a substance, or I'll say if a substance is taken with 1 gram mass, with an initial temperature, I am starting to boil that substance with a temperature of 14.5 degrees Celsius. In order to increase the temperature, I have to supply energy. So the energy is in the form of heat. Then the temperature will be increased to 14.5 to either 15.5 or 16.5 based on the amount of heat energy I will be supplying. So that is what is heat energy. See, heat energy is 1 gram of a substance with initial temperature of, for example, it is 14.5 degrees Celsius, has to be raised to some other temperature. The energy required is measured in the form of heat energy. Heat energy is measured by calories. So the energy required is 1 calorie. SI unit of heat energy is calorie. So 1 calorie is equal to 4.2 joules is the standard unit. 1 calorie is equal to 4.2 joules. Next, so this is about heat energy. Then what is electron volt? Electron volt, EV, small e and capital V is, we denote electron volt as small e and capital V. When an electron is accelerating, so when an electron accelerate, when an electron is moving around in its orbit around an atom, it will accelerate. What is acceleration? Showing a rate like velocity. When an object is moving with a certain mass, is moving with a certain velocity, we can call it as a the body is getting accelerated. isn't it? So electron, when it is moving in a circular orbit or any path, of course, it is undergoing an acceleration. So when an electron is accelerating, when it is moving itself, when an electron is doing some sort of work, it possesses some amount of energy. Yes, that energy is denoted by energy E, that is EV, isn't it? So the energy gained by an electron, of course the electron has to gain some energy when it is moving or when it is accelerating. So this energy gained by the electron when it is accelerated can be called as 1 volt. You will call that as potential difference. From one point, from A point, the electron is moving to B point. From A point, the electron is moving to B point. From A to B, there is a difference in its potential, in its charge, of course. So that is your potential difference. So this potential difference is measured by 1 volt. So that is your electron volt. Electron volt is nothing but when an electron is accelerating, the potential difference from its initial to final is called as electron volt or 1 volt. 1 electron volt is equal to charge of an electron into 1 volt. We know the charge of an electron is 1.6 into 10 to the power minus 19 coulombs into 1 volt. Then we know that coulomb by volt is equal to joule. So we are writing this as 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. This is your electron volt. So under energy we have studied heat energy and what is electron volt. Okay, and we have defined what is 1 volt and we have seen 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. In my next video, I will be discussing about different forms of energy and different types of energy in detail. If you like my video, please click like button, share it to your friends and don't forget to subscribe my channel. Your support is my strength. Thank you.